Use the unit circle to complete the table below by stating the exact values of the primary trig ratios of the given angles. Sine theta, you're looking at which? X or Y? Y. So all you're going to do is work your way around the circle, writing down the Y values, right? Which start at 0. And then they climb up. And then they start heading back down. And then they go negative. And then do the same thing with cosine. And then go back and do tan. Done. How about you? I will pause now. So we're going to use the table of values to sketch the graphs of sine theta and cos theta on the grids below. Note that the grid is scaled from negative 360 to 360, right? Now, we can just kind of do a little bit of symmetry type stuff, right? So let's start off by going from 0 to 360, right? And we'll use the decimal part of our table. And we're going to graph sine theta. So it's on the same page, right? So you just have to look to the left-hand side. I, on the other hand, have to do it all from memory. Okay, so for sine theta, right, we start off with 0, 0. Now, what are each of these little tickies? How many degrees? Degrees per tick. 90. Big ticks, 90. Little ticks?
15, I think.
Okay, yeah, just count them up, right? Just say, okay, so I got 1, 2, 3, 4, 5, 6 in 90, and 90 divided by 6 is 15. Now we don't have 15s, we have 30s, right? So we're going to go 30, but then we got 45, which will be one tick over from 30. Then we got 60, which will be one tick over from 45. Okay, so we're going to skip one because we want 30, right? And we're going to go 0.5 because that's what the sine of 30 is. And then we're going over one tick to 45, right, where we get 0.7 something, 0.71, right? I mean, as best you can. It's not going to be exact, you know, but it's going to be sort of a bit over. And then we go to 60 degrees, which is 0.87, which would be a little bit shy. And then we go to 90 degrees. And we just sort of keep going, right? So now we need 120 degrees, right? Which would be 2 ticks over because that's, you know, we've got to go 30 degrees. And, you know, it's kind of symmetrical anyway, so. And we skip 180. And we got to skip 2s. We got to go to 210. And next we go to 225, which is kind of like here. And then we get 270. 270, and we skip over a couple to 300, 360, right? So that's something like that, right? Then we join the points with a smooth curve, right? Not straight lines. Obviously, it's not straight lines here, right? I mean, you can't draw straight lines. So we make a nice smooth curve. There we go. Because I've drawn a lot of sine curves before in my life. So. And now we want to go this way, then we got to go backward, right? You know, symmetrical. But what you can do, see, here's what you can do, right? So if I want negative 30 degrees, that's really the same as 330, right? So you can just start at the bottom of the table and work your way back up to the top, right? So negative 30 plus 360 is like 330, right? So then you can just, so 30 is 0.5. And then 45 is here. And then we got this, and then this, and then this, and this. And then this, and that. Then we go over 2, and we go there, we go over 1. Go over 1, go over 2, go 2, there, and there. I missed it. Never mind. Go 2. Go 1. 2. There, sine curve, negative 360, 360. A little shaky, but it's on a smartboard. That's my excuse.
The right side is a lot better than the left.
Yeah, I know. I do. A function is said to be periodic if it repeats itself over regular intervals of its domain. Are y equals sine theta and y equals cos theta periodic? Do they repeat? Yes. The period is the length of the interval of the domain, which is the x values, right? Over which a graph repeats itself. The period of both y equals sine theta and y equals cos theta is domain x values. How many degrees?
720.
Really? 360, right? If you're looking at what's in front of you, you are seeing two periods, right? Because what did I just say about the sine curve, right? It starts at the middle, goes up to the top, back to the middle, down to the bottom, back to the middle, and then it repeats after that, right? So if you're looking at the far left edge of your graph, which you only have half drawn, which is why you're seeing the 720. Okay, sinusoidal data is periodic data whose graph could be represented by a wave pattern. Are y equals sine theta and y equals cos theta sinusoidal? Yes. The domain of both graphs is? No. That's the period. What's the domain? It's a set of all theta such that. What can you say about theta? Belongs to the reals. Right? For both graphs, the maximum value is, and the minimum value is Therefore, the range of both graphs is
Greater than 1, less than negative.
greater than or equal to. We start on the left, we work our way to the right, right? So low, less than or equal to y, less than or equal to high. Wait. The key has that. Okay, and let's end that off. It's a set. Part C, graph of the tan function. Use table values on the first bit. Notice, different scale, right? 0, 1, 2, 3, 4, blah, 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 right? Because tangent does not have a range of negative 1 to 1. So we need a different scale on here. No, this scale is the same, right? Still by 15, 15, 30, 45, blah, blah, blah. Okay? So we are to graph, let's graph the tan function. Okay, so now you may have to flip back and forth between your table of values, right, and the thing. So what's the tan of 0? 0. What's the tan of 30? 0.58. Okay, so 30 is here. What's the tan of 45? What? The tan of 45? 1. Why do you speak without knowing the answer? What's the tan of 60? This is not a question you can't answer. I'm not asking for speculation. When I say what's the tan of 45, I'm not saying please speculate on the possible values of the tan of 45. It's like give me the exact value from the table that you're sitting looking at. What's the tan of 60? 1.7. Alright, close enough. What's the tan of 90? Infinity. So we're going to draw a little asymptote line here. What's the tan of 120?
It can be it's infinity.
Well, so this line's going to do this.
It like never touches it.
Never touches it. Can't get there, right? You can do the tan of 89 degrees if you want. You can whip out your calculator and go tan 89. What's the tan of 89? Use your calculator, please. 57. What's tan of 89.5?
114.
Climbing pretty quick. What's tan of 89.9?
572 points.
Really climbing. What's tan of 89.99?
Are you just waiting for their calculators?
5729.57.
So you can see this is what's happening, right? Like as you get closer to 90, those values are going up a lot, right? I mean, it took from 0 to 45 just to hit 1, right? And then from 89 to 89.99, we all of a sudden were up like 5,000, right? So in the space of 0.99. So, yeah, what was 120? Here's 120. What's 120?
Negative 1.7.
Negative 1.78. What's 135?
Negative
Negative 1. What's one, whatever's after?
150.
150, that's it.
Negative 0.50.
Negative 0.58. What's 180? 0. What's 210?
0.5.
And 225?
1.
And 240?
1.7.
And 270?
Infinite.
All right, so here I seem to have a complete thing here, right? Because I got negatives and I got positives, so we know the positive end is going to swing up, and the negative end is going to swing down.
So it's like, also, that's a cubic function, isn't it?
No, that's a tangent function. I'm going to show you the easy way to draw the tan function.
But aren't like cubic functions?
Draw the X chromosome and kill half of it. I'm just guessing here.
What did I say about guessing? Yeah.
But it's a logical one. Unlike everybody else's.
Yes.
So over here it says like 10 and 90 is undefined. You don't have to say infinite. So
That's what undefined is.
well, the undefined means
Yep.
oh.
Okay, here's how you draw a tan function. You skip over 180 degrees, so we go to here. You got asymptotes that are running every 180, right? Starting at 90, so 90 and 270, and then negative 90 and negative 270. The middle is there at 45 degrees, so halfway between the middle and the asymptotes, right, you have a value of 1. And halfway this way, you have a value 1, 2, 3, a value of negative 1. And then you just start low and go high. So I have a 0 here. Now I can only show part of this, right? So 1, 2, 3, halfway, I have that value of 1, and then it just starts low and then goes up. And then over here, 1, 2, 3, 4, 5, 6. I got that 0, and it's going to go 1, 2, 3. Do that, and this, and there's 10. Theta. Okay, so really, just like here, see, with sine and cos, I only worry about the zeros and the ones, right? Got a 0, got a 1, got a 0, got a negative 1. Well, 0, 1, and negative 1, got a 0. With tan theta, I only worry about the zeros and the ones and the negative ones, okay? Where they are. Because you just, really, we're interested in drawing the shape of it. It doesn't have to be a terribly accurate thing. If we're going to solve something graphically on our calculator, then it'll be accurate. If we're going to graph it in some graphing program, it'll be accurate. If we're going to sketch a graph, then we just have to sort of know how to sketch the graph, right?
So we don't have to know.
So let's answer some questions. Is the graph of tan periodic? Does it repeat?
Yes.
Yes. The period is what?
Multiples of 90.
No. The period is what? Measured in degrees along the x-axis. How long does it take to run through one complete? 180. Thank you. So a complete set of values would be all of the negatives and then all of the positives, right? Why is the graph of y equals tan theta not a sinusoidal function?
Because we have like
Not a wave, right?
and we have asymptotes.
Not a wave, right?
Yeah.
Definition of sinusoidal is wave. This is not wave, therefore.
Therefore.
Yeah. It's a tangential. No, it's not. It's a tangent function. The range of y equals tan theta is. Yeah, y belongs to the real numbers, right? We get all values of y. The graph of y equals tan theta is vertical asymptotes at the theta values where theta is equal to. Where's the first one? 90. How far apart are they?
90.
So we're going to go 90 plus 180 degrees times n, where n belongs to integers, right? Which we indicate with a z, because we are Canadian. We say z. The general expression for the vertical asymptotes of y equals tan theta is. We just did that. Really? Okay, yeah, just take this, put it down there. And hence, the domain of tan theta is.
Set of real numbers.
Watch this. This one's kind of neat, right? So it's the set of all theta such that theta is not equal to 90 degrees plus 180 n degrees, where n belongs to the z's. So where the asymptotes are is where the domain are not. No, is not. So where there is an asymptote, it is not a valid value of the domain. Right? So we have to say the domain is where theta is not equal to 90 plus 180 n, where n belongs to the z.
Although how did we get 90 plus 180 again?
Again, he's like 2 minutes behind.
Oh my god.
Where are the asymptotes? Where's the first one?
We also have like asymptotes behind.
Yeah, go right. Where's the first one?
90.
Okay, how far apart are they?
180.
There you go. That's where I got that.
Because we also have the
Okay, so we go up here. If I want to find expressions, I always start with the positive, right? Because we like to be positive. So our first asymptote is at 90 degrees, right? I mean, how many asymptotes are there? In real life, not that you can see on the graph. How many asymptotes are there? Infinitely many. So we can choose any one, right? So let's pick the smallest positive asymptote, 90.
they're all
How far apart are they?
180.
180. That's where we get 90 plus 180n. Okay? Just remember when we did coterminal angles? We said it was theta plus 360n. It was like, what are the angles coterminal with 70 degrees? It's 70 plus 360n degrees, right? Because it will repeat. That terminal arm will be in the same position at 70 degrees, at 70 plus 360, which is 430, at 790, at whatever comes next, and so on. So here, these asymptotes repeat every 180 degrees, because that's the period of the tan function, right? So if you have an asymptote here, you're going to have one in 180 degrees. Or you had one 180 degrees back, right? So we make this integer. So that could be a 0, that gives you 90. Could be a 1, gives you 270. Could be a negative 1, gives you negative 90. Could be a negative 2, gives you negative 270. Okay, and that's the general expression. Where the asymptotes are, that's where the domain is not, right? You can't put that value in. I cannot give the tan function 90. Go ahead, type your calculator, go tan 90. Right? It's going to say error or undefined. Ooh, that's it.